Here's a useful way of calculating probabilities that are dependent events. So one event is influenced by the outcome of another event, and it's called probability trees. Read through this example. Start with 1 point and think of the outcomes of the events that can happen of this 1 point. A high school student can either play basketball in college or not A. We know the probability of a high school student playing in college is 6.1%. Therefore, the probability of a student not playing in college is 1 minus this. 1 minus 0.61. Okay, now let's look at the next event. We'll start at this top branch. If a student plays in college, he or she can either go on to play professional or not. 9.4% of the players who did play in college will go on to play professionally. This branch here, the probability is 9.4%. This is actually a conditional probability. It's the probability that someone plays professionally given that they have played in college. But if you don't like all the notation, you don't have to look at it that way. You can just use it as the tree. These branches always have to add up to 1. So the probability here is going to be 1 minus 0.094. Now let's finish off the branch. If someone doesn't play in college, they could still go on to play professionally, but there's only a 0.2% chance for those who did not play in college. Or they could not play. 1 minus that. Okay, we have all the possible outcomes and their probabilities. Again, each set of branches sums up to 1. We now calculate the probabilities in all the joint events. I'm going to make a column for my joint events and then their probabilities. I'll go branch by branch, the probability of A and B. If you look at your probability cheat sheet for formulas, this is calculated by the probability of B given A times the probability of A, which is exactly what I have here. Probability of A is the 0.061. Probability of B given A is 0.094. So simply to calculate this probability, I'm just going to take the 0.061 times the 0.094 to 4 decimals. Same thing here. Just to save some right, I'm going to skip the intersection of the probability of A and B, that's my event, and the probability of that is the 0.061 multiplied times 0.906. I'm going to go ahead and finish up the tree, A complement B, these two numbers multiply together. To make sure we've done it correctly, sum up all your probabilities. They must sum exactly to 1. We now have all the possible joint events and their probabilities, and we can quickly answer probability questions using the work we've just done. Let's look at part B really quick. What's the probability an individual plays in college and professionally? What's the probability someone plays in college and professionally? Simple. Go ahead and locate probability A and B, that number. Let's keep going. What's the probability an individual plays professionally but did not play in college? What's the probability that they do play professionally but they did not in college? Professionally and not in college. B and A complement this one here. Again, the order makes no difference for joint probabilities. Part D. The probability statement for this has no conditional or joint information. It's just wanting what's the probability of someone, a high school student, playing professional baseball, probability of B. We can use Bayes' theorem here. We will sum up all the possible outcomes of B, all the ways that B can occur. Probability of B and A, or probability of B and not A. Those are the two ways that B can occur. So we sum them up, or recall translates to a plus sign. Since I have my probabilities above, it's simple to grab those plus the low probability of playing professional baseball.